Hi, this lecture is about collision resolution techniques in hashing. So we'll be talking about what do you mean by collision, then some of the collision resolution techniques as well. So what is collision in hashing? Usually a hash function produces a hash value corresponding to a key. So you'll be having a hash table. So you are supposed to generate a hash value against a key, and by using that key you can insert using that hash value you can insert that key onto the hash table, or the reverse process, that is if you know the key, then you can search for the hash table and so on. So based on that, the record has to be stored at some particular location in the hash table. Sometimes if the hash table produces the same hash value for more than one record, such a situation is called a collision. So a collision is a situation where two key values or two records are demanding for the same index location in the hash table. So two records are coming, and for both the records, if your hash function is producing the same hash value, then both has to go to the same location in the hash table. That means that only one can sit there in only there is only one room for only one element there. So you should find out another alternative place for storing the other record. So that is what collision resolution is. So if the hash function that you are using is producing the same hash value for more than one record, that situation is called a collision, and we will see how collision resolution can be done. Basically, there are two methods. One is using separate chaining. The other one is open addressing. Open addressing has got three different techniques. One is linear probing, quadratic probing, and double hashing. We will see one by one. Separate chaining method. In separate chaining, let's take this example. We have elements like 25, 36, 64, 49, 4, 16, 9, 81, 0, and 1. Let's say we use a division method here. H of key is equal to key mod 10. 10 is the total number of or total size of the hash table. So separate chaining is a method in which along with each entry in the hash table, we have a linked list like structure. So along with 0, you have a singly linked list. Along with 1, you have another singly linked list. 2, you have another singly linked list. That sort of a structure is used in the case of separate chaining method. For example, h of 25, hash 25 is generated like this: 25 mod 10, you will get 5. So instead of storing it here, you will create a node, a linked list node like this. You can store value 25 here and link to the next field here. There is no next field here, so it will be stored a null value in this link. Then h of 36, 6 will be stored, and the next link will be null. Then comes, for example, 64. In 64 also you will create a node, and that next link will be null. Then comes 49. 49 also can be inserted by creating a node like this. Next node will be null. Then comes 4. For 4, you can see that this was not pointing to null. This is pointing to an entry. So you go to that element and you create a new entry here. It's like inserting a node at the end of the linked list. So you have a corresponding linked list for each of the entries, and inserting a node in the sense you insert an entry in the end of that linked list. So searching also will be done in a similar fashion. We cannot say that searching will be done in order of one time here, because, for example, if you have, in the worst case, the search operation may take order of n also. For example, if all the elements are getting produced with a single, what do you call, single hash value, then entire entries will be stored just like a singly linked list. So in order to search for a key value, you will have to go through the entire elements in the singly linked list. So order of n time will be taken for the same. So this is called separate chaining. Let's look at open addressing methods for collision resolution. Let's take the sample 22, 11, 32, 71, and 46. Here again, I'm using the division method. That is, key h of key is equal to key mod 10. Then the first entry h of 22, 22 mod 10, you will get it as 2. Then you can store that value in 2 here. Second location h of 11 equal to the second element from the sample. You will get 11 mod 10 equal to 1. This can be stored at this location. Then the third entry, that is 32. H of 32 is 32 mod 10. You will get again 2. In 2 there is already one entry, so that is collision. This entry is a collision. So what you do is, you in linear probing, you just try to find out the next blank space. This entry, that is the position 3, was blank. So instead of saying actually 32 should be stored here, but there is no room for 32 here, so you will take the next entry, that is next position. So that is what linear probing is. H of 32 equal to, actually it is 2, but you will store it in 3. H of 71 equal to 1. Yeah, it should be stored here. It's again a collision. So you will take the next blank space. Next blank space is here, fourth position. So you'll store it here. 46, you can store it here. 46. That's it. So that is linear probing. Whenever there is a collision, you check for the next blank entry linearly, and in the next blank position you will store that value. That is what is linear probing. Then quadratic probing, here also we are using the division method. H of key is equal to key mod 10, 19, 18, 39, 29, and 8. Here, if there is a collision with this hash function, then we'll use another hash function. That is what you mean by quadratic probing. This quadratic function will be used. H of key is equal to key mod 10, for example. Key mod 10, 19. 19 will be stored in 9th location. 18 mod 10, 18 will be stored in 8th location. These two entries are stored without any collision. Then the next entry comes 39. H of key is equal to key mod 10 is 9. Then that should not be stored here because that position is already filled. Then we'll calculate h dash of 39. 39 plus 1 square, key plus I square, key plus I square mod 10. That is done. I can take values from 1, 2, etc. 10. With I is equal to 1, if you are not able to store the value, then we'll use I equal to 2 and so on. For example, h dash 39, 39 plus 1 square mod 10. 40, 40 mod 10 is 0. So 39 should be stored here, sorry. 39 should be stored at 0th location. Then 29, 29 also should be stored here, but there is no space. So what we'll do is 29 plus I square, 29 plus 1 mod 10 is once again 0. 0 is already occupied. So what we'll do is we'll calculate 29 plus 2 square, 29 plus 4 divided by mod 10. So you'll get 3. 29 will be stored at this location. So that is That you mean by that is what is quadratic probing. Linear probing and quadratic probing are facing some of the problems associated with linear probing and quadratic probing are clustering problems. With linear probing, you can see that there is a primary clustering. Primary clustering in the sense you can see that the elements will be clustered at this position. If it is not able to store here, then the next position, then the next position. So always there will be clustering at the initial positions in the hash table. That is the property of linear probing. So we call it primary clustering. Primary clustering is an important problem associated with linear probing. But in the case of quadratic probing, the problem is that if half of the table is full, then it is difficult to find room for newly added record. That is another issue with quadratic probing, that we call it secondary clustering. So if half of the table is full, then once we do it, this key plus I square method, then you will always end up in a position where there is that is already occupied. So that sort of a problem is called secondary clustering. So in order to overcome the problems associated with primary clustering and secondary clustering, we can use another method known as double hashing. In double hashing, once again we use the same division method for storing the key. And if there is collision, for example, the elements 1, 2, 3 are stored in locations 1, 2, and 3 without any collision. 1 more 10 equal to 1, 2 more 10 equal to 2, 3 more 10 equal to 3. These elements are already stored. Now if you take 11, 11 more 10 is already 1, so there is collision. In that case, we use this method or this hash function. H dash of key is equal to m minus key mod 10. H dash of key is equal to m minus key mod 10, where m is a prime number which is smaller than the hash table size. So in this case, let's see an example. Uh, let's see an example. H dash of key is m minus key mod 10. Key is equal to 11 here. So we'll take m as 7, which is less than a prime number which is less than 10. Then h dash of 11 is equal to 7 minus 11 mod 7 equal to 3. So you will get this as, so you'll get it as 7 minus 11 mod 7. 11 mod 7 equal to 4. 7 minus 4 equal to 3. So double hashing, in double hashing technique, what we do is we had collision at this position, isn't it? 11 11 mode 10 was actually 1, and in that case we were having collision. So collision happened at this position. Now we apply the second hashing method. H dash of key h dash applied means we got this value 3. So we take 3 jumps from here. So from here 1, 2, and 3. In that position we'll store our this position. So that is what you mean by this h dash value. So h dash of key, you get some value, you make that many jumps from the position where collision occurred, and you insert the element there. That's how we insert the elements. For example, in the case of 12, h dash of 12 is 7 minus 12 mod 7. So you get the value as 2. From here you had collision, so you make 2 jumps from there. 1, 2. Here this is already filled, so you make 2 more gems. You installed you insert 12 at this position, at the position 6. For example, in the case of value 13, the key equal to 13, you will get this as the position actually, but this is already occupied. There is collision. So you apply this h dash function. H dash is equal to, you will get it as 1. You make one jump, they're already filled, so you make one more jump, you can insert the element here. So that's how you do double hashing. So these are the different methods for the collision resolution. We have seen separate chaining method. Separate chaining method, along with the hash table, we have to use separate chains of or separate linked lists for in storing your data elements. While other case like open addressing case, that is in linear probing, quadratic probing, or double hashing, we'll be storing the elements in the hash table itself. We don't require any additional storage space here. But there are difficulties in linear probing and quadratic probing. In linear probing, it faces difficulty like primary clustering, and in quadratic probing, there is a problem like problem in the sense there is a difficulty with secondary clustering. So in order to overcome that, you can come up with a solution, namely double hashing. So that's all about collision resolution techniques. So based on this, you need to submit an assignment on hashing methods and collision resolution techniques. So you need to, I'll be giving a link for uploading your assignment in Google Classroom. You need to upload it in time. The assignment is implementation of hashing methods or hashing functions, different hashing functions which we have discussed in the previous class, and you try to implement all the different collision resolution techniques as well. Thank you.